I'm just trying to decide how I want to show you the next thing. So we're going to change it up here just a little bit. Implicit differentiation. Now, we've seen implicit differentiation before, right? This is not the first time we've ever seen this before. I'll ask you to remember, recall, from Cal 1, if you had something like xy squared equals sine of x plus y, then it would be impossible for us to isolate y. So we would use implicit differentiation, and what we could do is we could find here, dy dx, right? We'd be able to find that. We could also do dx dy if we wanted to. If we do dy dx, that means we treat y like it depends on x, and then here we treat x like it depends on y. And so we take a derivative on both sides, right? That's the way implicit worked. Should I work through this or no? No? Okay, so just recall that. Now what we're going to do is, let's say that we have our goal here. Let me show you the end first, and then we'll see how we're going to get to it. Our goal here is to take something like 6xyz. X cubed plus y cubed plus z cubed plus 6xyz equals 1. And to find in this the partial of z with respect to x and the partial of z with respect to y. What's that? Yeah, so how did we do the partial of z with respect to x? We held y to be constant, didn't we? And there what we were saying is that z depended on x and y, right? So what we've done before, okay, before this problem, what we had done before is if I gave you something like z was equal to x sine xy, right? This is the problem we've been messing with. We could find the partial of z with respect to x, and the way we did it is we took the derivative of the left side with respect to x, which was partial z with respect to x, yes? And then on the right side, what we did is we held all our y's constant, and we did the product rule, and we got sine xy plus xy cosine xy, right? That's it? That's what we did? So we did left side and then right side. Why can't you do that here? Okay, the z's not isolated, right? The z's not isolated. So we could just come through here, right? We could come through here and do, what's the derivative of x cubed with respect to x? 3x squared. Derivative of y cubed with respect to x. So we're treating y as a constant. So derivative of that? 0. Derivative of this? 3z squared. partial of z with respect to x. Good. Here, what would you have to do? Y is a constant, so you'd have to do product rule in here, yes? So we could do this, okay? We could, but it's not as clean as this one is, right? This one's just here, and then do this, and then we're done. But because the z's mixed in with this, it creates more of an issue. Do you all understand that? So what we're going to try and do is we're going to come up with a formula that will allow us to do this a lot easier, okay? Rather than having to go through all this tedious stuff, all right? So let me see if we can come up with this formula. I hope it works out. Okay. All right, so the road to a formula. Let's try and get road to a formula. All right, let's suppose, have I shown you all that symbol? I know some of you I've shown. In mathematics, that's what we use, S with a little line, that's what we use for the word suppose, all right? So suppose we are given something like this. Z is some function of x and y, all right? Let's say we are. Then what I'd like for you to do is I'd like for you to move, just look at it as an equation, move it to the other side, and do you agree with this? Do you agree with that? Just algebraically move it to the left? Yeah? Okay. We are going to take this left side of the equation right here. Notice that there's a 0 on this side. I'm going to call this, I'm going to define this to be capital F of x, y, z. I'm using capital F so you don't mix it up with this little f. But I'm not saying that this is the antiderivative or anything like that. Just I'm going to call this entire side, the left-hand side of that equation, capital F of x, y, z. Okay? Now, the next part is I would like for you to draw me a tree for this situation right here. Tree. If I want to know what capital F is, what does it depend on? I have x, y, and z. Do you all agree with that? Yes? Okay, now this is the part that's tricky. Remember the idea here. How can I do this? Let me get the problem that was the goal up here. Remember this was our goal? That was our goal, to be able to find the derivative there. If I give you x, or let's say, I knew I was going to have trouble with this. We are assuming that y, all right, that z depends on what two things? X and y, right? Agreed? Because that's from here. Now, we did this, we all said that z must depend on x and y. Yeah? Now, this is the tricky part that doesn't seem natural, but let's just draw it. You know how the bottom row of our tree always had the same thing in it? Like it was either all t's or all r and s or whatever? I want to make all my branches here have the same values. Now just watch for a second. X depends on x. That's obvious, right? Y depends on y. That's obvious. This is not so obvious. Y depending on x and x depending on y. Right? That's not as obvious. But in some sense, if z is given up here, right? If z is given, then you could isolate. You could say that y and x would be left, so y somehow depends on x. You could also do it the other way. If z is given, then you could have y and z, or x and y in there. You could say x somehow depends on y. So these two are not completely out of the realm of like rational thought to think that that would be okay. Let's just see where it goes. All right, just bear with me. What would What derivatives are possible here? So tell me what derivatives would be possible in this tree. What's possible is partial. Possible would be partial capital F, right? Partial capital F with respect to x and partial capital F with respect to y. Nope, because look, the bottom row is what we're going off of, right? Because if I know x and y, then I'll know z and back up. All right, let's look at the partial of f with respect, capital F with respect to x. Let's look at just this one. Partial capital F with respect to x would be equal to, I'm going to go down which branches here. Go down here, right? And then down here, right? And then I'm going to go down here and down here. And then down here and down here, right? Those are my branches. Questions? Okay, let's try this first one. Here to here is partial of f, capital F, with respect to x. What about this branch? Partial x with respect to x. That's like dx dx. What's dx dx? It's 1. So, but that's not going to matter. I mean, we'll get to that later. Then I come down here, partial capital F with respect to y, and then partial of y with respect to x. Yeah? And then this one, partial capital F with respect to z, and then partial z with respect to x. So it's very similar to what we did before. Yeah? All right, let's write this formula down. This will be what, partial, god dang it. What is it? This times this, right? So partial f with respect to x times partial x. I'll write down partial x plus down this way. Partial f with respect to y times partial y with respect to x plus one more. Partial f with respect to z times partial z with respect to x. Y'all still with me? What is this equal to right here? 1, that's a 1. So can I erase it? Okay, that's a 1. Aren't these the same? Subtract it on both sides. Right? I can subtract as this is addition between those. If I subtract this on both sides, I get a 0, don't I? So I'm going to get 0 equals partial capital F with respect to y times partial of y with respect to x plus partial f with respect to z times partial z with respect to x. Now, I know I've kind of taken us on this weird journey, okay? But I'm going to take you back just before we continue here. I want to take you back to our goal. Our goal was to try and look at that and find two different things. Partial z with respect to x and partial z with respect to y, which would be easy to do if we could solve this for z, right? We can't solve it for z, so we're trying to use some sort of implicit differentiation. So I did some weird shit, and then now I'm doing all this, and I've gotten us to here. And you're like, okay, now what? Let's just focus on this one. Do you see that in there? You see it? Yes? Okay. I would like for you